So, starting our inorganic chapter, we're dealing with compounds that are made out of metals and nonmetals. Um, this these are called minerals, right? Minerals are ionic compounds, but minerals make up rocks. The rock cycle happens because of plate tectonics. That's how we get all these different types of rocks, which are all these combinations of minerals. So that's kind of what we're going to go through today. So first of all, what are minerals? It's an ionic compound where the cation is a metal, the anion is some sort of nonmetal. We consider them inorganic. That's the word for an ionic compound, is an inorganic compound. And they form sort of this like crystal structure because of the positives and negatives. So you can see here, this is the structure of tridymite, I think is how you say that. But this is what the rock actually looks like in real life. But this is the structure, the ionic structure, where we have what's called like a tetrahedral shape. So a center with the four points all connected in this little center here. That's a tetrahedral shape. And then they're sort of flipped. We have like a one facing down and then one facing up and so forth. But they make a very organized structure. Minerals have an organized structure like this because there are positive parts of like this tetrahedral. This might be positive up here where this is negative, so it's giving us sort of a polar molecule, a separation of charges. Or it is ionic, where we have like a completely positive charge and a completely negative charge. Here we have fluorite. That's the structure for fluorite, and it's this really, really pretty crystal down here. Here we have pyrite. You may have heard of pyrite before. It's this like gold colored, you might have seen that. It's pretty common, but again, it has a structure here made out of iron and sulfur. So what happens, right? These minerals are naturally occurring compounds that are on our earth. They're naturally occurring, and they make rocks through kind of a bunch of different processes, but we sort of have three main types of rock. Igneous rock, which comes from magma being heated or cooled. And I'll show you on the plate tectonics like where we would come in contact with like the magma or like the lava from underneath the earth. We have metamorphic rocks, which usually come from high heat and high pressure, and then sedimentary rocks, which usually come from weathering and erosion, where we're sort of breaking apart minerals and then we're smushing them together with high heat, high pressure. So those are our three main type of rocks. It takes a very, very long time to form a rock, because it usually involves, again, the breaking down of minerals, either physically or, well, always physically, but physically either through like pressure or through heat. And then the building back up again through pressure or heat. We have three layers of the earth. Well, we have three major layers, crust, mantle, core, but we have definitely all these other little tiny layers in here. So the lithosphere is what we consider the crust, which is the oceanic and the continental crust. And then right below the very, very top of the mantle, that's what we consider the lithosphere. The asthenosphere is below that, and that is the mantle. This is a like liquid part of the mantle, or at least what you would kind of consider liquid, whereas the lithosphere, the top part of that mantle, is solid. In the asthenosphere, that's where we get like the magma, the convection currents, where it gets closer to the center of the earth and it starts to heat up, and then because its heat rises, right, it gets pushed up toward the crust where it starts to cool down, and we get sort of like a convection cycle there. But it can do that because the asthenosphere is mostly, it's like it's a thick liquid. It's like a kind of what you see as lava. It's a little thinner than that, but it's liquid-like. And then the core, we usually talk about like an outer and an inner core. The core is mostly made of like iron. We haven't like actually been to the core, but we think that it's made of iron because we do have like electromagnetic fields around the earth. We'll get to that more in physics, but those are all the parts of the earth. So what we're talking about now for the rock cycle, we're mostly talking about the asthenosphere and the lithosphere. So how are rocks actually formed in the asthenosphere and the lithosphere? Well, these plates that you see here, these are major plates. There's a bunch of more like minor plates, but they move. They either rub against each other, which right here, this is where we are, right on in California, and this is called a transverse fault line, which means that right here they sort of like rub against each other. That's why we get earthquakes that tend to like shake a lot. There's also subduction zones, which is where like one plate goes underneath another. And then there's also convergent, which is where two plates kind of push up against each other and make like a mountain range. And then like here in the middle of the plate, somewhere right here, at least the North American one or the Pacific plate, there's Hawaii. Is that Hawaii right there? Some of these islands are Hawaii. And those are what we call hot spots, where the magma like breaks through the crust of the earth and sort of creates like volcanoes. So most of the time volcanoes are created at fault lines, but every once in a while they're created in the middle of a plate with a hot spot. But the reason Hawaii is like a bunch of different islands like in a row, so you can kind of see there's three here. Obviously we know Hawaii is more than that, but there's a couple that are all in a row. That's because they were created over time as the plate shifted. So as the plate moved, the hot spot then moved and created different islands. So in, a couple hundred years, could we have a new Hawaiian island? Maybe, especially since the volcanoes there are still active. That means that the hot spot is still active. So when the plates move together, we have this picture here is the subduction, which is where you have one plate basically going underneath another. It creates a trench, and then again with a like it can create like a mountain range, not necessarily always volcanic, but it can be. This is just a really cool picture, but this picture down here shows the convection currents. So we have it getting hotter as it gets closer to the earth. We know hot rises, and then as it gets closer to the outside of the earth, like the lithosphere, it cools back down and goes back to the core, and so forth. So it creates this like circular convection current. And so when that happens, that's where we get this high heat. So as this comes up, it is cooling down, but it's pretty hot, right? So it's high heat. So as minerals and rocks are being sort of like crushed here, they're becoming really, really hot, and they're starting to, be smushed together with other minerals. And those minerals are then brought out into the outer part of the earth, either through what is this called? A subduction zone like this, where we get these mountain ranges, right? The colliding of the rocks here will eventually work its way into a mountain range, or a trench. Or again, even with the transverse where they sort of slide next to each other, again, that's high pressure, and it can still be high heat because we still have these convection currents happening underneath. So the bottom of that lithosphere, the top of the asthenosphere is still pretty hot. It does cool down, which is why the lava goes back down, but again, or magma, but it does still come up warm. So high heat, high pressure, that's where the rocks are. So here's just like a molecular visual representation of the convection current. So again, when something is hot, it rises. As it gets further away from the heat source, it starts to cool, and then cool molecules slow down and they start to fall. They get heated again and they go back up. That's kind of how a lava lamp works. It's the same idea, but we call it a convection current. So this is if you have like a convection oven, this is how it works, where you have a heat source at the bottom, hot air rises, it cools toward the top of your oven, so it sinks back down, and we get this circular motion of heat. So that's basically the gist of plate tectonics, how plate tectonics affect the rock cycle through these plates moving, right? We get high pressure, high heat. That's how rocks are formed. And then what are rocks formed from? They're formed from minerals, which are inorganic compounds or ionic compounds, which are made from like a metal and a non-metal. Again, minerals are naturally occurring, so all of these minerals, these three examples I gave you, but plus thousands more, they're all naturally occurring. So they can all be then formed into rocks. This is why when you pick up rocks, like a rock from the ground, you might see a little bit of like a silvery color, and then you might see like white parts, and you see all these different parts because there's a lot of different minerals mixed into one. Um, so that's the unit that we're starting, is this ionic compound, this inorganic unit. And this is sort of the big picture of it.